Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. Now we'll interface 8 red LEDs with port B of microcontroller using ULN2803 Darlington driver. We will use 8 390 ohm resistors to connect all 8 LEDs with port B of microcontroller. Before interfacing all 8 LEDs, first we'll make a room for these 2 relays and we'll see where to place these relays on our Vero board. Here we will place these 2 relays on our Vero board and we'll place 2 green connectors here. Here we can find green connectors con 1 and con 2. So we'll reserve the place for relays on right hand side of our Vero board. And here we will place 8 LEDs and we'll place the base for ULN2803 near to microcontroller port B. So let's start interfacing 8 LEDs with microcontroller. Here we have 8 red LEDs and 390 ohm resistors. We'll interface all these 8 LEDs with port B of microcontroller. We'll keep the distance of 0.3 inch between each LED so that we can connect all 8 LEDs in a presentable way. Here we can find the hole in our Vero board is at a distance of 0.1 inch. First we'll connect 8 390 ohm resistors at a distance of 0.3 inches with each other. Here we have soldered all 8 resistors in our circuit. Here we can see we have connected all 8 resistors in our circuit. Now we'll connect 8 LEDs with these resistors. Here we can see the small pin of LED is cathode and the large pin of LED is anode. So we'll connect the anode of this LED with resistor. Here we have soldered one LED with resistor. Here we have connected all 8 LEDs with resistors. Now we'll connect one end of all these resistors with 5 volt and we'll connect second end of all these resistors with anodes of LEDs. We'll connect cathodes of all 8 LEDs with ULN2803. Now we'll connect the power supply selection jumpers to select the power supply for 7-segment displays, LEDs and LCD circuit. Here we have header pins. Now I'll solder these header pins in Vero board. Here we have soldered the power supply selection jumpers in our Vero board. The first jumper setting will select the power supply for 7-segment displays, and second jumper setting will select the power supply for LEDs, and the third jumper setting will select the power supply for LCD display. So I'll connect the middle pin of these jumpers to the resistors of LEDs. We have soldered all the resistors with the center pin of these jumpers. Now we'll check the continuity of the resistors with the center pin of this jumper. Okay, the resistor is connected properly. All 8 resistors are connected properly with the center pin of this jumper. Now we'll connect opposite pins of these jumpers with the 5 volt. And here we have 5 volt on pin number 2 of our programming interface. Now we can check that all these 3 pins are connected with 5 volt. We will check the continuity of these pins with 5 volt. Okay, we have connected power supply jumpers with our prototype. Now we'll connect all anodes of LEDs with resistors, and we'll connect the cathodes of all LEDs with ULN2803 dial-in-turn driver. For this we'll use a 18-pin base to insert ULN2803 in our prototype. Here we have inserted the base for ULN2803. Now we'll connect cathodes of all 8 LEDs with ULN2803 dial-in-turn driver. We'll connect port B0 of microcontroller with this LED, and we'll connect port B7 of the microcontroller with this LED. So I'll connect pin number 18 of ULN2803 dial-in-turn driver with the cathode of this last LED. Now we have connected cathodes of all 8 LEDs with ULN2803 Darlington driver. Now we'll connect rest of the pins of ULN2803 Darlington driver with microcontroller and ground. We'll also connect pin number 10 with 12 volt power supply. Here we can find pin number 31 of microcontroller is ground. So we'll connect pin number 9 of ULN2803 with this ground. Now we'll check the continuity of pin number 9 of ULN2803 Darlington driver with ground. Okay, pin number 9 is connected with ground. Again, we'll check if there is any short circuit between power supply and ground connection. Okay, there is no short circuit between 5 volt and ground connection. So the driver circuit for 8 LEDs is completed. Now we'll connect inputs of ULN2803 Darlington driver with port B of microcontroller. As we can find, the LCD connector is directly connected to the port B of microcontroller. So first we'll develop the connections for LCD connector. Then we'll connect port B of microcontroller with ULN2803 Darlington driver. Here we can find pin number 1 of LCD is ground and pin number 2 is 5 volt. Pin number 4 of LCD is connected with RB4. Pin number 6 is connected with RB5. Pin number 11 is connected with RB0. Pin number 12 is RB1, then RB2, RB3. Pin number 15 is connected with 5 volt and pin number 16 is connected with ground. Pin number 15 and 16 are connection for backlights. First we will connect the 5 volt to the pin number 2 of LCD. Again we will use the power supply selection jumper to power up LCD. And we will connect the pin number 3 of power supply jumper to provide the power supply to the LCD. Here we have developed a route for power supply for LCD connection. Now we'll check the continuity of 5 volt connection for LCD. Here we have inserted a pin in header connector. Now we'll check the continuity of LCD power supply with this jumper. Okay, 5 volts are connected with LCD. Now we'll establish rest of the connections for LCD interface.